This is section 8.2, arithmetic sequences and partial sums. So start with the definition of what an arithmetic sequence is. A sequence is arithmetic if the differences between consecutive terms are the same. So the sequence A1, A2, A3, A4, and so on and so forth is arithmetic. If there's a number D such that if you do A2 minus A1, and then you do A3 minus A2, and you do A4 minus A3, that you always get the same value, the same number, the same quantity, and that quantity is called the common difference of the arithmetic sequence. Okay? So something like, 1, 3, 5, 7, 9 is arithmetic because no matter what term, if you take away the previous term, we have a common difference of 2. That would be arithmetic. If it went 1, 3, 5, 7, 19, well, then now you've got a difference that's not 2 anymore, so it would not be an arithmetic sequence at that point in time. All right. Let's take a look at some examples of arithmetic sequence. The sequence whose nth term is 4n plus 3 is arithmetic. Write the first 5 terms and determine the common difference. So again, to get the first term, I plug in 1. So 4 times 1 plus 3 is 7. Plug in 2. 4 times 2 is 8, plus 3 is 11. Plug in 3. 4 times 3 is 12, plus 3 is 15. Plug in 4. 4 times 4 is 16, plus 3 is 19. And you plug in 5. 4 times 5 is 20, plus 3 is 23. And those are the first 5 terms. The common difference, if you take any term and subtract the term before it, we get 4 for a common difference. Okay. Let's take a look at B. The sequence whose nth term is 7 minus 5, or 7 minus 5n is arithmetic. Write the first 5 terms and determine the common difference. So we plug in 1. 7 minus 5 times 1 is 5. 7 minus 5 is 2. We plug in 2. We get 10 here. So 7 minus 10 is negative 3. Plug in 3. That's 15. 7 minus 15 is negative 8. Plug in 4. We get 20. 7 minus 20 is negative 13. Plug in 5, 25. 7 minus 25 is negative 18. And the common difference is every time it goes down 5. Do negative 3 take away 2, we get negative 5. The sequence whose nth term is 1/4 of n plus 3 is arithmetic. Again, for first 5 terms, find the common difference. So if I plug in 1, I get 1 plus 3 is 4. 4 times 1/4 is 1. Plug in 2. 2 plus 3 is 5. Times 1/4 is 5/4. Plug in 3. 3 plus 3 is 6. 6 times 1/4 is 6/4. But 6 over 4 simplifies to 3/2. We plug in 4. 4 plus 3 is 7 times 1/4. We plug in 5. 5 plus 3 is 8. I get 8 over 4, which simplifies to 2. My common difference is, take any term, I'd probably do this one. 5/4, take away 1, which would be 4/4, is 1/4. And then, similar example, it's just on the flip side, show that the sequence whose nth term is n squared is not arithmetic. So let's write a few terms of the sequence. Let's plug in 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And to be honest, that's enough. That's all we need. Because if I do 4 minus 1, I get 3. But if I do 9 minus 4, I get 5. I get a different difference. I don't have a common difference. So it's not arithmetic because there's no common difference. Sorry for the penmanship on that. All right, let's move on. So by looking at the 3 examples of arithmetic sequence, it should hopefully become evident that arithmetic sequences grow linearly, and as such can be represented in a form that mirrors, that looks very much like y equals mx plus b. Now, when we look at m is the slope. Now, what slope says as x increases by 1, it's how much y increases by. Now, when we do sequences, n is the 1, n is the m here, the slope. It's the number, it's the x value. Let's try that again. N is the x value. It's the amount that we're going out on every single term. So 1, 2, 3, 4. An is the output, the y value. So m is how much it goes up every single time. That's the common difference. So x is our n, y is our a sub n, b is the y-intercept. Okay, the y-intercept happens when the input is 0. Well, if the input is n, then b is a 0. That's the 0th term. Now, just real quick, a 0 we can get by taking the first term and subtracting that common difference, just kind of looking at the first term and going back one term. So we'll see that as we go forward. So real quick, the nth term of an arithmetic sequence has the form an equals dn plus a0. So here it is. Here's the y equals mx plus b, where d is the common difference or slope between consecutive terms of the sequence, and a0 is the 0th term, also known as the y-intercept, or a1 minus the common difference. So again, in linear terms, d is the slope and a0 is the y-intercept. So example 2. Find a formula for the nth term of the arithmetic sequence whose common difference, so d is 3, and whose first term, that's a1, is 2. So we need a0, so I'm going to start with that first term and back off 3. Okay, so if I go back 3, then we get to -1 for a0. Now, if you want a little bit of justification for that, remember, take a term, subtract the term before it, and we should get that common difference. So if a1 is 2, then when I solve this equation by subtracting 2, I get negative a0 is 1. Therefore, a0 is -1. And now I'm good. We can write our formula. So an equals dn plus -1, which we just write it as -1. Now, what I would do at this point here is check. I mean, what do we have for terms? We know the first term is 2. So let's plug in 1. 3 times 1 is 3, minus 1 is 2. So that checks off. We unfortunately don't have any other terms. We could find them, though. And we'll be doing that as we go through some more of these examples. Okay. The example 3, the fourth term, so a4 of a sequence is 20, and the 13th term is 65. Write the first several terms of the sequence. All right, so to kind of give you an idea, the way I look at this is, again, I look at it linearly. So my input is 4, my output's 20. My input is 13, my output is 65. Remember, d is the common difference, or the slope. We do slope by taking y2 minus y1 over x2 minus x1. So d is going to be 65 minus 20 over 13 minus 4. So I get 45 over 9, which is 5. I get a common difference of 5. Now from here, we could do a couple quick things here. So if I could say A4 is 20, then A3 is going to be the term that is 5 less than that, which would be 15, because again, we go up by 5 every time. So that's A3. A2 would be 5 less than that, or 10. A1 is 5 less than that, or 5. So there's the first several terms of the sequence. Okay, now, the problem is if I gave you a 40 or something like that, then you can't necessarily back it off. So let's go ahead and just kind of work through how we do this. All right, so I'm going to erase this for just a second. All right. So I would take a point. So we have AN equals DN plus A0. So let's plug in N, so that's 4, and we get out 20 plus A0. So 5 times 4 is 20. Subtract 20, I get A0 equals, well, a little strange, but A0 equals 0. So what that means is AN, my formula, is just 5N. So now let's write the first 5 terms of the sequence. Plug in 1, we get 5. Plug in 2, we get 10. Plug in 3, we get 15. Plug in 4, we get 20, which checks out. Plug in 13. 5 times 13 is 65, so that checks out. So we could continue that pattern. So this is the way that I would do it most of the time. If I'm given a small enough number, it's easy just to back off to get the first few terms to go down to A1. But quite often you're given things like A10 and A13, and then it's a lot harder to consume more time to try to back off all the way to the first term. Find the seventh term of the arithmetic sequence whose first two terms are 2 and 9. So A1 is 2 and A2 is 9. So my common difference right off is 7, which means A0 would be 7 less than that, or -5. And there we go. So my sequence is going to be dn plus -5. And we need the seventh term. So A7 would be 7 times 7 minus 5, which is 49 minus 5, or 44. Let's take a look at the next piece, which is adding up the terms of an arithmetic sequence. So the sum of a finite arithmetic sequence with n terms is given by n over 2 times a1 plus an. What I want to show you very quickly is we're going to use that formula on example 5. I'm going to erase it, and then I'm going to show you really kind of how that formula comes to be. All right, so here's how it works. We have how many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So n is 10. A1, the first term is 1, and the 10th term is 19. These are the three pieces of information we need. How many terms? The first term, and then that last term. And so I get the sum is n over 2 times the first term plus the last term. Let's see here. 1 plus 19 is 20. 10 divided by 2 is 5. So I get 5 times 20, or 100 for a sum. So what I want to do real quick, I'm not actually, I won't erase it. I'm going to go ahead and leave this here. I'll just open up a new one. So if we have 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, 15, 17, and 19. This is one way that was shown to me that I can kind of justify where that whole formula comes from. Here's the idea. Take that list of numbers and reverse the order. So 19 plus 17 plus 15 plus 13 plus 11 plus 9 plus 7 plus 5 plus 3 plus 1. Add straight down. I get 20. I get 20. I get 20. All the way across, we get 20. Now, how many 20s do we get? Well, we get the same number of 20s as we have terms, which is 10 terms. So we get 10 times 20, which is 200. Now, the problem is I have added up the sequence twice. So therefore, I have to cut it in half. So now let's put all of this together. 10 is the number of terms. 20 I get by doing the first term plus the last term. Technically, I could do the second term plus the second to last term, but we can't really do that because we won't always know what those pieces are. And then we cut that whole entire thing in half. And therefore, we get the formula that S is equal to n over 2 a1 plus an. So how about the sum of the integers from 1 to 100? Well, how many numbers are there? We have 100. My first one is 1. My 100th one is 100. So the sum is going to be 100 divided by 2 times 1 plus 100. I'm going to leave you to calculate and verify that that does indeed come out to 5,050. There's a nice little legend associated with B that deals with a famous mathematician who was supposedly mischievous in his early elementary years, and one of his consequences was to add up the numbers from 1 to 100, and he absolutely shocked the teacher by doing it in just a matter of mere moments. And the way that he did it was very much the way that I showed you back on this previous page here. So find the 150th partial sum of the arithmetic sequence 5, 6, 27, 38, 49. So what do we have here? First of all, I have 150 terms. That's what we're looking at. A1 is 5. The problem is A150 is unknown. I don't know what the 150th term is. I know 5 of the terms. I am not going to add up and find out what the 150th term is that way. So what I want to do is I'm going to do what we did earlier, which is find the common difference. It's arithmetic. So 16 minus 5 is 11. I'm going to then back 11 off to find the 0th term. A 0 would be 5 take away 11, which is -6. Put those two things together. AN is 11n minus 6. So now I can find the 150th term just by plugging it in. And I'll let you verify this. This does come out to be 1,644. And so now I've got everything I need to find the sum. So the sum is 150 over 2 times 5 plus 1644. And that comes out to be 123,675. All right. So that's it for the notes. So there are a series of problems there. What I will be posting, as well as the homework, PDF of the homework, is I will post. I'm not sure if I'm going to do it for you guys on this Friday, but later on at some point, I will post the solutions so that you can check your work. But that should be good enough. Don't forget, you can always look on YouTube and find some other examples out there as well. All right. Have a great day.